Good afternoon. This is Haejin Jang from the University in Seoul, Korea. My presentation today is concerned with explainable AI model for text-based novelty analysis. Here is the list of contents consisting of introduction, related backgrounds, the main part of the proposed model, ongoing results, and the last one, conclusion. Let's start with the introduction. My research is interested in technology novelty, and analyzing it has been an important research topic in technology R&D management. As you can see, various applications for technology R&D management, including technology opportunity analysis and trend analysis. It is also an essential requirement in patent examination in all countries of patent office. Therefore, it is crucial to evaluate the patent's technological novelty when applying for a patent. Many prior studies have developed novelty indicators to measure technological novelty using structured and unstructured information of patent database. For example, in the case of structured one, they measured by combinational similarities using backward citation and IPC code, and using text mining approaches. Prior studies developed indicators through outlier detection based on keywords or subject action object structures. And more recently, several studies have attempted to develop a deep learning based model that classifies novelty between patent document pairs. Indeed, I have more interest in the deep learning based approach because it has advantages beyond the prior indicator based one. First, it is possible to examine the contents of the patent document itself, not using substitute information like existing IPC code or cited information. In addition, it can learn the hidden features of patents by utilizing the accumulated patent big data. However, deep learning based model approaches have limitations so far. First, prior researchers built a model in a similar way to the ordinary classification task, which means they did not reflect the characteristics of technical elements, such as the features of complicated technological information. Second, deep learning model constantly has a controversial issue that it is a black box model. However, it is imperative for patent examination to explain why the model predicts that the pending patent is novel or not just its binary results. So to overcome these limitations, we developed an explainable AI model for evaluating the technological novelty to examine whether a patent document secures technological novelty compared with prior patents. And we also consider the technology elements and principles in patent claims. In detail, from the model operation point of view, we develop a deep learning model that is both learnable and interpretable classifier. We are going to cover the details of data construction, model architecture, and evaluation in the following parts. And chapter of backgrounds, there are two subparts, and the first one is prior researches on technological novelty. And we already reviewed these references, but in this chapter we have summarized them in detail according to 5 perspectives, including analysis unit, features, and perspectives on novelty and its application. In this study, we set analysis unit in a pattern texture document level for application of evaluating novelty on pending patterns. So it is very recent studies are increasing. And the second part is a self-explaining text classification model, which is used as a backbone in this study. So the model consists of input and intermediate and interpretation, and the last one output layer. Input layers takes the stack of word representation using board embeddings, and the intermediate layer is located on the top of input layer with the K encoder stack consisting of multi-head attention. And span information collecting layer is placed on the top of intermediate layer here, which enable direct measurement for salience based on text span, like from to text span information. The interpretation layer aggregates all text span information and drive output of a weighted average of all span representations. We chose this model as a XAI backbone because it is simple with a self-explainable method and flexible for revising the input and intermediate layer for our target task. From now on, let me explain the proposed method in this study. The main goal of the model is to classify the novelty in a binary class 1 or 0 with a document pair of target pattern and a prior pattern. And the prior one is selected in a document corpus dataset. To do this, we propose a framework for evaluating pattern novelty, which consists of the 3 processes. In a data construction, we suggest how to build a pairwise document set for input. And second, we propose an XAI model for pattern novelty evaluation by reflecting these representing the features of pattern document in a sentence block and document feature level, including these splitting claims, document relations, and tag words. Finally, we added proposed post-processing the output of the model for better application in the pattern explanation. Let's move on to the following parts of the detailed processes for data construction. We use EP full text data set in EPO, which contains basic bibliometrics and all low texture information and search reports. In search report, you can get novelty related categorical information, and we focus on class X, which means appending a pattern is related enough to prejudicial to the novelty of prior arts claim with specific claims of pending patent and descriptions listed in a prior patents. So we get pairwise document data set at a final version by parsing these HTML type of raw data, and we add pending history because EP full text data only provide application version patent with last two digits of A1. So not a registered patent of B1. So using pending history, excluding application A1, revision version of A9, and register B1, we can augment a single pattern with a multiple cases. So at first, we suppose that registered pattern B1 is acknowledged for its novelty. Although a pending pattern get X class, all the cases X classes, but it registered without any revision, so it has only A1 and B1, and we interpret it admit its novelty at a whole document novelty. So just for the 11 claims and description level, the class will be 0, but in all claims level, the class will be 1 because it registered without any corrections. On the other hand, in a case of register after revision, it has A9. So we augment original one, A1. Whole document level also refers to novelty prejudicial, which is class 0. And in the same way, B1 refers to class 1. Through this, we can keep balancing dataset for each class and get cases from different classes with a similar technical content. So we expect these processes make smaller learn well in a tricky circumstances. So in the second process, we propose a model. At first, we put a bigger emphasis on reflecting features on technology information. So these 3 features are considered for the input. When it comes to dealing with claims of pattern, its lengthiness is obstacle for the embedding. So we apply the previous myth model for splitting long form document matching block. It can be a solution for our task of long pairwise document. Second, we extract claim dependencies to reflect the structure and successive relation. In general, NLP model, a dependency parsing information enhance the model performance. So in that way, we expect the claim dependency to be same. At last, we only consider the important technical terms, not all words and word information called a tech word, which is my previous work study. Tech words are extracted from noun phrase and SAO structures by network similarities for its importance between words. The proposed model architecture are considered as this figure, and input layer is looks so complicated, but it's made up by technology-oriented input features, and intermediate and interpretation layer are constructed, followed by a backbone model, output layer provides novelty classes with tag-word span information explanation. We propose additional post-processing of explanation for its applicability. At a pairwise document level, we expand the pattern pair for all prior patterns with prediction. So it is helpful for filling in a search reports. Also, in more micro level, we analyze a single claims with technical information, technical elements, using NP and SAO based tag word. So from now on, I'm going to present the ongoing research. First off, I want to say sorry that I don't share the result of all processes. I wish to let you know the paper as soon as possible. First, we downloaded EP full text big data part, including basic bibliometric, text information, and search reports. And we pre-process the HTML format into pairwise document dataset. So with proposed augmentation process suggested in this study, we get around 80,000 cases in half and half classes, almost. So using pre-processed dataset, we are learning in learning with the following model configurations, including BERT model for embedding, encoder, and train evaluation loss configuration. Due to the data size and length, we have struggled with memory issues. So after model training is supposed to pre-process the model output. At the last of validation, we consider both model performance in ordinary and the comparison test. We have two comparison tests, and the first one is to compare with ordinary NLP input and technology-oriented input suggested in this study. So we compare the quality of text pen information for explanation and computational cost. The second one is to compare with prior indicator-based approach, so to illustrate the implications of differentiators of qualitative rate. At last, in summary, we propose XAI model for examining technology novelty in a pattern. So we have academic contribution points that it constructs annotated pairwise data set for supervised based deep learning model using search reports. Also, we suggest an explainable XAI AI-based approach, which reflects the features of technical information. However, it is ongoing study, so we have a lot of to do in the further process. So also, I think that there are several limitations, but among them, the one is it is different text data fields between target and the prior, because in target patterns we use claims and we use descriptions of prior patterns. So in further study, we analyze at an identical claim level in the future. Thank you for listening. So, if you have any questions and comments, feel free to discuss. Thank you.